Hello again, everyone. In this video we're going to take a look at service-oriented architecture, and I had originally set this up so that I was going to do two 10-minute videos on understanding SOA, and I realized after I kind of laid out a lot of the details that I wanted to talk about inside these videos that 20 minutes just wasn't enough. So instead of doing 20 minutes in two parts to talk about SOA, I'm going to do 3 videos in 3 parts, so I'm going to call this 30 minutes to understanding SOA instead of 20 minutes to understanding SOA. There's still a lot of stuff we got to cover, so I'm going to talk pretty quickly here. So in this first video we're going to talk about service-oriented architecture, and this is going to be part 1 of a 3-part series. This is going to be part 1 of 3, and in this video we're really going to focus on the A in service-oriented architecture, and we're going to talk about architecture. In the second video, we're going to talk about how code is laid out and how to actually create applications that fit in the service-oriented architecture model. And in the third video, we're going to talk about the business benefits of SOA and why businesses should be looking at adopting this technology for their enterprise type applications. So like I said, in this video we're going to really focus on architecture, and we're going to have a little bit of a history lesson. We're going to go back to the 60s and 70s. And what was the main architecture? And architecture is just a fancy word for saying how do we lay out our applications. In the 60s and 70s, things were pretty easy. There was really only one type of architecture out there. You had a mainframe, and accessing this mainframe was something called a dumb terminal. So here's our mainframe, and you had users accessing the mainframe via dumb terminal. The dumb terminals were called dumb because they didn't do any processing themselves. They were just kind of a conduit. So users would interact with an application. They would send the information off. The dumb terminal would send that information to the mainframe. The mainframe would do whatever it needed to do as part of the application and send the information back to the dumb terminal. So nothing really happened here at the dumb terminal. It was just kind of like I said, a conduit. So the pros of this type of environment is what? Well, it's relatively easy. You know, when you're creating applications, you know where they're going to live, you know the environment that you're going to deploy them on, develop them on, you know, whether it's COBOL or some other kind of programming language. You know how they're going to be accessed. They're going to be accessed via this dumb terminal. The cons that go along with this is something called scalability. Scalability refers to the fact that how is the application going to handle when, number 1, more users come on board, and number 2, when more application functionality is developed. So the mainframe really is doing everything. So you don't have a lot of scalability here, right? The mainframe is going to hold the data, it's going to hold the business logic, it's going to hold any type of presentation logic. And presentation is just, you know, how information is displayed back here. Because the dumb terminal really doesn't do anything, the mainframe has to do it all. So if there's a way of presenting the data, like it has to be formatted on the screen, whether it's a report or some, you know, crude graphics that are going to be drawn on the screen, the mainframe has to do it all. The dumb terminal doesn't do anything at all because, you know, it's just a conduit. So it is relatively easy to handle applications in this kind of environment, but again, the biggest con that we have is scalability and being able to handle new users and new functionality inside of our application. In the 80s, what started happening? Well, we started seeing a lot of users use PCs to access information. So you still had the mainframe here, but a lot of the work that the mainframe was doing could now be offloaded to the PCs, right? So stuff like presentation. Oh, going off the screen here. The presentation can be handled by the PC. If I had to draw a graph or I wanted to look at data in some different way. The PC could handle doing a lot of that stuff. The mainframe could just be isolated to hold the data. We could also distribute the business logic and stuff like validations, right? Something like that could happen at the PC level. A real simple example, let's say you had a gender field that you were inputting for your employees. You could have the PC do the validation and say, did they put an M or an F for the gender field in there without even having to go to the mainframe. That's a real simple example. Obviously, you can do a lot more complex things here. But under the old dumb terminal thing, the dumb terminal can't do any processing. So every time a user put in information, we had to go to the mainframe would have to validate the information, send it back to the dumb terminal. Now the PCs can handle a lot of that stuff. So what are we doing? We're isolating a lot of the data that goes, we're isolating a lot of the different pieces of an application, and we're really turning the mainframe into just kind of a data server, right? Now, not all the logic has to live here in the PC. You probably still have some business logic here in the mainframe level also. So what are the pros of this? Well, we get another layer of scalability. Right, because the PCs are going to do more and more of the work. It's easier to add new users to the system, easier to add more business logic and stuff like that. The cons really come down to maintenance. Biggest problem we have at this level is, okay, well, let's say I have 5,000 users who are running some application. When it comes time for me to update the application, whether I'm doing a bug fix or I'm handling more functionality inside my application, I have to go to 5,000 PCs and update the application on all these different PCs. Now, there were some monitoring things and some things you can do at the administrative level to make that easier, but it's still really a hassle to update an application on all of these different PCs. This method also, by the way, before I forget, was called client server. The mainframe obviously was the server, the PCs were the client. Another problem you had is all the PCs had different configurations. If you were working in a large organization, you might have users who are running Windows 95 and Windows 98 and Windows 98 SE and Windows 2000 and 2000 Service Pack 1 and XP Service Pack 1 and XP Service Pack 2. Getting all of those PCs to work with whatever application you were working in could be a real challenge, and that was a real nightmare for a lot of organizations in this model. So we solved a couple of things here, but we introduced some new problems here in terms of maintenance. In the late 90s and the early 00s, we had what became known as three-tier architecture. And you can substitute 3-tier with N-tier because you can have a whole bunch of tiers. And what were the three main tiers? Well, you had a server that probably held a database and other important business logic. And then you had an application server in the middle here. And then you had your clients, which were usually PCs running a browser. So, do we have scalability? Absolutely. We can add more application servers at this level if we want to. We can have a cluster of those and have a load balancer here to handle all the different PCs that are going to be accessing information. We can cluster our servers together. And again, this is probably where our data is going to be living and some business logic. We've also straightened out a lot of the maintenance issues that we used to have, right? Instead of going a whole bunch of different PCs and updating an application, we just update it in one place, right? We update it at the application server. So when we have to roll out some new functionality or a bug fix, we just roll it out to the application server. The PCs access the application server. They get the new application. Application server interacts with the data server that handles all of our business logic. So, the pros certainly are scalability and maintenance, But what's the con that we're dealing with here? Well, we're getting to a high level of complexity. We're looking at a true distributed system here, and it's hard to figure out in a lot of cases in these large applications, where does the code live? So if I have some basic validation code, does it live in a JSP? So it's living on the browser where we're doing our validation here. Is the validation going on here inside the application server? Is the validation going all the way right down to the database level? Our business logic is going on over here. So again, we solved some significant problems, right? We have really true scalability. We've eliminated a lot of the maintenance issues that go along with this kind of situation. But this is getting really, really complex in terms of how we construct our applications. Do we have standards inside the organization to say, okay, this is where we're going to put our business logic. Are we going to put our business logic here all on the mid-tier? This is what we're going to load up on. Are we going to push it down to the PC level? This can be a real challenge in terms of how we're going to architect all of these different systems together. So let's see if I can get this scrolled up here. So, what happens in the late OOs? We have this concept of service-oriented architecture. And what service-oriented architecture does is, okay, the complexity of these applications that are going to be distributed across all of these different tiers. What we're going to do is we're going to take a look at isolating each one of those individual pieces, right? So if we have this really complex application, let's say like a typical enterprise resource application, like an ERP. So we have stuff like Oracle, eBusiness Suite Release 12. That's a real common one. SAP is a common one also. And these applications hold a little bit of everything, right? They have accounts receivable, accounts payable, general ledger, purchase orders, inventory, management, a ton of different things that go along with these applications. One of the things that we can do is we can say, let's isolate those pieces. Let's isolate those pieces and call them a web service. And a web service is like a black box. It's like a real simple black box that has a limited amount of functionality, and it's exposed at the application server layer, and we can access any of these web services that do a real specific thing. So if we have an enterprise system like this, where we have accounts payable, accounts receivable, all of these different modules that go along in our back office, what's a good example of a web service? Well, we might have something like a credit check. That might be an example of a web service that's out there. Credit check does exactly what it sounds like. Maybe I put some vendor information in, how much money we want to give them credit for, and it goes out and does an analysis out on the web of the organization, how likely they are to pay their bills back and everything like that, and gives us back some credit score. And then as part of our application, we look at the credit score and say, okay, yeah, we're going to give $1 million worth of credit to this vendor. This other vendor doesn't have such a great rating, so we're only going to give them $250,000, something like that. That takes away a lot of the complexity. If we can break down each one of our pieces that are distributed across this architecture into these web services, we have a lot of flexibility. We have flexibility in terms of understanding the complexity, of isolating the code that goes on inside the web service. Imagine if I had this gargantuan application that was distributed over all of these different tiers, and somebody came to me with a request that says, you know what, we need to change the credit check algorithm. Where in the world am I going to find that stuff? It could be anywhere, and especially if it's a really large system. If I've isolated these into web services, it gives me the ability to go in there and say, hey, I can find this information. I can use this credit check web service across all of my different applications inside my organization. This large ERP system may not be the only place I need to do credit checks. There may be other point-of-sale systems where I need to do a credit check as part of my organization. I can reuse this code over and over again and give me a level of modularity that I don't have, that goes beyond like a traditional application that's deployed over this three-tier architecture. So in terms of the architecture point of service-oriented architecture, This is really the kind of evolution that we've evolved to in this state, is looking at isolating these really large applications and isolating individual pieces of the applications that we can then expose as web services. In the next couple of videos, we're going to take a look at some of the other things that go along with service-oriented architecture. But this is the first in a three-part series that really talks about service-oriented architecture from the ground up, and hopefully will give you a better understanding of why service-oriented architecture is so important in today's development world.